22 years of experience in electronic components, including film capacitors, ceramic components, and resistor products. After this presentation, we will have a live Q&A with Grishela. You can submit questions at any time using the chat box that you can see on the right-hand side of your screen. So thank you, everyone, for joining us. And with that, I'll hand it off to Grishela for the presentation.
Good afternoon. My name is Grishela Saldua Price, and I'm the Senior Product Marketing Manager for Varistors and NTC ICL in Rush Current Limiter, and we're part of the Piezo and Protection Devices group within TDK. In today's session, I would cover the National Electrical Code and the current changes, and also talk about the surge protection innovations. With the recent revisions to the National Electrical Code, they are set to impact surge protection strategies across various applications, affecting both existing and new designs. In this seminar, we'll explore the latest surge protection technologies and discuss how TDK solutions align with these updated guidelines. First, it is important to understand what NEC is. NEC, or the National Electrical Code, or sometimes referred to as National Fire Protection Association, or NFPA 70, is a United States standard for the safe installation of electrical wiring and equipment. It is part of the National Fire Code series published by the NFPA. Shortly after Thomas Edison's Pearl Street Station was installed in New York City in 1882, electrical fires have become so common, and that is when the first National Electrical Code was implemented in 1897. It was understood that a standardization was much needed. A group of 1,200 individuals came together and set the very first national rules for electrical installations and operations. In 1911, the National Fire Protection Association became the sponsor, and the code has been revised on numerous occasions since that date. Now, it is revised every 3 years. It is important to note that the NEC is not a U.S. law. However, it is commonly mandated as state and local law. That said, the NEC codifies the requirements for safe electrical installations into a single standardized source. The authority having jurisdiction inspects for compliance with these minimum standards and is regionally adaptable for electrical best practices. This means states can adopt the code requirements they feel necessary for retrofitting or inclusion into new dwellings, which can be found on the International Association of Electrical Inspectors, or IAEI, website via educational requirements. The NEC is the most widely adopted code in the world, and it is approved by the American National Standards Institute, or ANSI. NEC is the most complete set of electrical code requirements that govern electrical installations in the interest of safety for persons and properties, whether it's residential, commercial, or industrial occupancies. This objective has remained constant throughout the NEC's existence, and the principles it contains continue to grow and change with the dynamic electrical industry. As we already have established, NEC is always evolving to accommodate the rapid technological advancements and the changing needs of modern facilities. Initially, the houses, commercial and industrial buildings have a much simpler electrical or energy requirements. As we evolve into integrating smart technologies and automation, the NEC has made significant strides in integrating tech-first features into its guidelines. The latest code will have an impact on both old and new structures in the coming months and years, as revisions for cable requirements, EV charging, lighting systems, and surge protection will all need to be addressed. Older commercial buildings will have to be updated or replaced existing infrastructure to maintain compliance, which could prove costly depending on the electrical systems. Newer dwellings will lessen that impact as most have adhered to the 2020 NEC codes, which outline the required electrical panels, outlets, surge protection, and appliance guidelines. The 2023 NEC, for instance, introduced new provisions that reflect the growing influence of smart technology in building design and renovation. These additions aim to ensure that the integration of these technologies into our buildings and facilities is done in a manner that prioritizes safety and efficiency. Let us now understand what are some of the major electrical code changes. In the new 2023 NEC, it took effect on July 2024. There are about 30 new guidelines that was implemented. Some of them are the use of ground fault circuit interrupter or GFCI protection in dwelling units, working platforms, kitchen areas, specific appliances, and outdoor outlets. The use of branch circuits such as arc fault circuit interrupter or AFCI protection for garages, lighting outlets, exhaust fans, gas fireplaces, guest rooms and suites, and other occupancies such as fire, police, ambulatory stations, or the likes. The use of receptacle outlets on countertops and work surfaces, and the addition of emergency disconnect services for one and two family dwelling units, and the use of surge protection devices or SPDs. It is the whole structure surge protectors that are typically installed at the main electrical service panel and can protect any devices connected to the entire building, specifically for dwelling units. For a complete list of the changes, please refer to the NFPA website. For the purpose of this seminar, we would like to focus more onto the surge protection devices portion. Surge protection devices, or SPDs, are technology that are designed to safeguard electrical and electronic equipment from voltage spikes or surges, which can occur during lightning strikes, utility grid switching, or when high-powered electrical equipment is switched on or off. When a spike or surge occurs, protection technologies can divert excess voltage away from devices and appliances, preventing damage. There are two types of SPDs. The whole house surge protectors are typically installed at the main electrical service panel and can protect any devices connected to the entire building. The other type is a point-of-use surge protectors. This is a plug-in system designed to protect specific devices and equipment such as personal computers, appliances, entertainment systems, and more. The code requires either Type 1 or Type 2 surge protection for services supplying all dwelling units, including single and two-family and multifamily residences. Surge protection devices must be located within the service equipment or adjacent to it. To keep the surge protection closer to the protected loads, particularly in a multifamily unit, the surge protection device can be installed at each dwelling's load center or panel board. Why is the whole home surge protection now mandatory, even for repaired or replaced equipment? This code change was made to safeguard vital safety-focused electronics in a household, such as GFCI devices, smoke alarms, and heat detectors. These protectors work by utilizing high reliability components such as metal oxide varistors or MOVs and gas discharge tubes GDTs that conduct excess voltage to the ground. TDK offers a wide lineup of voltage protection devices that includes both disc varistors or metal oxide varistors and surge arresters or gas discharge tubes. They can be used for various applications ranging from low to high currents. Varistors can be used for protection from transient overvoltage, such as electrostatic discharges or ESDs or lightning surges. Furthermore, chip varistors or CTVS are suitable for protection from small surge currents and electrostatic discharges or ESDs. Gas discharge tubes voltage protection devices feature low capacitance and high insulation resistance. They are suitable for high-frequency signal lines because of their low capacitance, for example, less than 1 picofarad. A little bit more details on the metal oxide varistors. TDK has a wide range of metal oxide varistors. Varistors can be used as suppressors to protect devices and circuits from transient abnormal voltages, including an ESD or electrostatic discharge and a lightning surge. For protection from a relatively large surge current, about 100 amps up to 25 kiloamps, leaded disk varistors and SMD disk varistors are suitable. For protection from a larger surge current, approximately 25 kiloamps or more, block varistors and strap varistors are more suitable. For industrial devices and energy apparatuses, disk varistors of which maximum allowable circuit voltage, or commonly known as rated voltage, and maximum peak current are largely used. Leaded disk varistors, SMD disk varistors, strap varistors, black varistors, and we also have what we call thermofuse varistor. It is best to understand first the difference between a conventional varistor and a varistor with thermally coupled fuse. Generally, metal oxide varistors are used to protect electronic devices against overvoltage surges. However, several events can cause a thermal runaway in a varistor, and the circuit protection function of the component can no longer be guaranteed. Those events may result in the end of life of the varistor, or even shortly before that, or if the varistor is exposed to abnormal overvoltage conditions. A thermofuse varistor prevents the described failure mode with a hybrid design. It integrates a varistor and a thermal element into one component. A disk varistor is set in series with a thermally coupled fuse. While the temperature is increasing, the thermal element starts to melt, and a spring disconnects the varistor safely from the power line and avoids the reconnection. This increases reliability and protects the equipment. Varistors with thermally coupled fuse are safer than single varistor components. In certain conditions like fluctuation of the voltage levels or frequent surge pulses, single varistors are in risk of thermal runaway, and engineers tend to use more reliable solutions like the TDK thermofused varistors instead. Further, additional monitoring function allows to detect the status of the component, which is also getting a more popular feature. Thermofused varistors are fulfilled to more higher market standards such as the UL 1449 Type 5 up to Type 1 CA. As shown in the chart, we offer multiple types of thermofused varistors. We have our housed version, leaded NT series, and our new MT series. As already described, thermofused varistor is a hybrid design that integrates varistor function and thermal fuse function into one single component. Let us look at the main differentiating factors of our MT series. Here is an internal construction of the thermofused varistor. The new thermofused varistors are specially developed quadratic disc varistors, which are connected in series with a patented thermal protective component designs. For these types of components, PPS housing technology is more commonly used. So why are we using overmolding technology? First, the use of epoxy material can withstand higher temperature. This ensured the varistors to survive in critical conditions. Second, with the low injection pressure process, it greatly reduces the risk of mechanical damage of the disc varistors. Third, stable injection speed results in a more homogeneous molding process. And lastly, the use of low temperature alloy makes a thermal disconnection more constant and precise. Similar designs in the market have thermal solder joint at leads or distance to the disc position. With TDK's flat spring design, it has a direct connection to the central area, allowing to sense heat very quickly. The spring function triggers and forms open mode during an overheat event. The thermofuse element is a smart construction of slider and thermal slider joint in combination with the indication leads to track the status of the components. When there is an overheat event, the thermal solder joint heats and disconnects in a very short time. The slider then rotates and prevents from reconnection, and then in the indication leads disconnect while slider rotates and changes the signal status as shown below from normal mode to open mode. With this technology, MT series provides a fast and reliable disconnection, and therefore prevents an open mode reconnection and stops arcing to occur. TDK has released the MT series MT25 and MT30. MT25 covers a voltage range from 150 all the way to 385 AC voltage with maximum surge current capability of 20 kiloamps at a pulse form of 8/20 microseconds according to IEC 61643-11. This series offers the same performance with approximately 20% smaller dimension and has a built-in indication leads function compared to what is currently available in the market. MT25's monitor outputs are optionally available with or without electrical isolation. MT30 are designed for voltages from 150 all the way to 750 AC volts. Its maximum surge current capability is 25 kiloamps at a pulse form of 8/20 microseconds according to IEC 61643-11. The monitor outputs of these varistors are designed with electrical isolation. The series offers better surge performance and fulfills the common standard such as UL 14491CA, and it's also tested at 200 kiloamps at short circuit current rating or SCCR test on a more compact design. Both of our MT25 and MT30 series has a good dump heat performance and can pass live tests under damp heat according to EN 50539, which is 40 degrees Celsius, 93% relative humidity at the component's DC voltage rating up to 500 hours. Additionally, TDK will be releasing a new addition to MT series, MT40. Utilizing similar design structure as MT30, MT40 meets all the industry standards such as UL 1449 Type 1CA and tested at 200 kiloamps short circuit current rating test. This series will cover a voltage range from 150 to 550 AC volts with a maximum surge current capability of 50 kiloamps at a pulse form of 8/20 microseconds according to IEC 61643-11. MT40 offers a better damp heat performance and can pass live tests under damp heat at 85 degrees Celsius, 85% relative humidity at the component's DC voltage rating at 500 hours. The samples are already available upon request. With a compact and smart integrated design, MT series meets harsh environmental conditions requirements and is a very cost-effective solution for various industrial applications. Potential applications include photovoltaic inverters, industrial power supplies and inverters, outdoor lighting and telecommunication systems, and Type 1 and Type 2 surge protection devices applications. To summarize, the NEC has released a new edition of the code that reflects the market trend, and it incorporates the smart technologies in new builds and renovations. These revisions were put in place to ensure that it prioritizes safety and efficiency of each occupants. Installations of SPDs has additional advantages beyond the safety factors outlined in the 2023 NEC. Manufacturers and consumers are shifting to increasingly sensitive electronics in everyday appliances and devices. For example, the lifespan of electronic chips found in today's refrigerators, laundry equipment, entertainment centers, and even smart lighting can be extended when an SPD is introduced to combat power surges and voltage spikes. So it is essential to follow the articles and standards set forth by each new revision of the NEC. The latest 2023 edition of the NEC was issued by the NFPA Standards Council on August 2022 and took effect on September 2022. This officially became available for federal, state, county, and municipal governmental entities to update their electrical installation regulations. According to a map issued by the NFPA, 13 states have already adopted and completed their 2023 NEC update process. 7 states currently using the 2020 NEC, 2 using the 2017 NEC, and 1 state currently using the 2008 NEC and have commenced the process of revising the statute or administrative rule through which the NEC is updated to reference the 2023 edition. And 1 state currently using the 2017 NEC is in the process of updating to the 2020 NEC. So we can see the progress as it goes, and we hope that this gets completed very shortly. Thank you for taking your time attending our session today. We hope that you find the presentation materials a valuable learning experience. We're waiting for your feedback, and we hope to hear from you soon. Thank you.
Thanks, Grishella, for that great presentation. We already have several interesting questions, but I want to let our audience know that there's still time to submit your questions, so use that chat tab up on the right-hand side of your screen. Okay, so Grishella, are you ready to answer some questions? Excellent. Make sure your mic is on. Is your mic on? There you go. I can hear you.
Okay.
Good. Okay. First question. How have the recent revisions to the NEC specifically impacted surge protection strategies?
Yeah, so basically when the NEC 2020 was introduced and later the NEC 2023 version, it's now requiring that all services supplying the dwelling units, they need to be provided with an SPD or surge protection devices. And basically with that new requirement, it increased the market demand drastically. So the SPD manufacturers have been focusing on expanding their production capacity. And also, as the main purpose of NEC is to offer protection and safety for everybody that's occupants, it requires that SPD manufacturers ensure all products meet the industry standards, just like the UL approvals that have been implemented.
Got it. Next question. What are the key differences between surge protection requirements for existing designs versus new designs?
Sure. There's a few differences that exist between the NEC 2020 and the 2023 surge protection requirements. For example, in 2020, it requires that SPDs in dwelling units that include multifamily units. This requirement includes both for new construction and also for the replacement equipment. However, in the NEC 2023, it was further clarified that the dwelling units include dormitories like guest rooms, guest suites of hotels and motels, patient sleeping rooms like hospitals, like nursing rooms, and some other like limited care facilities. Also in NEC 2023, it added section 409.7 that requires the replacement of SPDs to be internal or immediately adjacent to control panels that support personal protection. And it also supports the manufacturer's instructions to keep the SPD lid length short enough.
Got it. Yeah, it sounds like it's getting more and more comprehensive. Yeah.
Yes.
Next question. What are the latest advancements in surge protection technologies that address the NEC updates?
So the 2023 NEC revisions for surge protection now requires either a type 1 or type 2 surge protection device for all the services supplying a dwelling, or the NEC states like a unit. This provides a complete and independent living facility for one or more persons and require an SPD that locates within the equipment or adjacent to it. To that end, like type 1 protectors must be placed on the load or service side of the electrical panel, while type 2 are designed to be placed on the load side only. And there are various types like type 1 and type 2 SPD technologies that are basically designed for like entire buildings or point of use protection. This can be used like a surge protected breakers or single phase surge protection devices or electric surge suppressors or outdoor transient voltage surge suppressors. Also like control panel surge devices, single phase meter load, surge protection, and different other things like that.
Next question, specifically about TDK's products. The question is, how do TDK's surge protection solutions align with the updated NEC guidelines?
So in the NEC 2023 updates, it requires that the SPD shall have a nominal discharge current rating of not less than 10 kiloamps. And TDK, we offer two different thermofused series for this application, in which one of them is the MT30, and it's designed for voltages from 150 to 750, and it provides a maximum surge current capability of up to 30 kiloamps. And the MT40, it's designed for like higher voltages of up to 550, and this one has a maximum surge current capability of 50 kiloamps, surpassing the requirement of NEC of 10 kiloamps. And both of the series actually also fulfill the common standard of UL 1449 Type 1CA, and it tested at 200 kiloamps for the short circuit current rating.
Okay. Next question. This is a very specific question. The question is, should I use the ETF V25 or the MT25? The MT25 looks more robust, he says, but the data sheet shows better energy absorption for the ETF V25. So what are the differences that are important?
So the ETF B25 is actually one of our older thermofused burster version. The MT25 is definitely a more robust type, but for specifically for surge protection devices, we recommend the MT30 or the MT40. The MT25 is rated at type 4, while the MT30 and the MT40 is rated type 1CA, which is what's required in the new SPDs.
Excellent. Okay, next question. What industries or applications are the most affected by these NEC revisions, and how can TDK's technologies mitigate these challenges?
Sure. The NEC revision is mainly concentrated on the surge protection devices in the SPDs, and it's mainly for residential or commercial dwelling units. Basically, its main purpose is for safety and protection. And in addition to that, the manufacturers and the consumers are shifting to increasingly like using more sensitive electronics or appliances and devices like that. So, for example, like nowadays, the lifespan of like the electronic chips um, for like appliances, like smart lightings, like anything that you basically use or you plug in, it when you use an SPD, it helps to protect for any type of power surges or voltage spikes. So with our voltage protection product offering, it basically we offer like a very high reliable products that can withstand and help with those over voltage spikes that occur during the lifetime of the products.
Excellent. Well, Grishela, it looks like we covered all our audience questions. So I want to thank you again, Grishela, for a great presentation, and thanks for sticking around for the Q&A. Before we wrap up, I'd like to announce our prize winners for this session. So congratulations to Helena Cristobal and Tom Schuster. Those are our winners for this session. But I also want to announce our grand prize winner for today, and that is Gordon Marjalou. And you've won today's grand prize courtesy of Mauser Electronics. And we'll be in touch with all these winners to find out their information so we can send you the prizes. So thank you, everyone, for joining Industry Tech Days 2024. And thank you to our giveaway sponsor, Mauser Electronics. And I also want to thank our event partner, Electronica. If you happen to be in Germany, November 12th or 15th, check out their show. I'll be there as well, the Electronica Trade Show in Munich. So in a moment, you'll be redirected to TDK Electronics exhibitor booth. And I encourage all of you to check out today's other live sessions, keynotes, and published content. So thank you, Grishella. Thank you, audience. Thank you.